So, today we're going to do basic algebra. Algebra is essentially texting in maths. What we're doing is we're throwing away some of the symbols like the multiply sign and the divide sign, and we're sticking these numbers and letters together. So we're going from longhand to shorthand or back again. So basically this lesson should be too easy for you by the time you get to it, because what I'm going to teach you today is text speak for maths, which is, in a sense, algebra. So the first bit of the lesson is all about this text speak. The posh word for text speak, our buzzword for text speak, is something called notation. Okay? So when you see in maths, what is the notation for this? It's just the way we put these numbers and letters together in algebra. The second part of the lesson should take 10 minutes at the end, and this is where we have to define certain things called a term, an equation, a formula, and an expression. You have to know what each of those four things are very specifically, because in the exam they will test you very specifically on them. They will ask you to circle the expression, circle the term, which term does this. So if you're not talking the talk with those four buzzwords, it gets quite difficult and you will start shedding a lot of marks. Tomorrow, we're saving the fun tomorrow. And this is where we start simplifying algebra. We start doing something called expanding brackets, and we start doing something called factorising. Factorising is one of those words for a lot of 16 to 18-year-olds. It sends a shudder down their backs because they've never been able to do it. And we're going to blow away the myths for that. We're going to make it a process that you'll get your head around. So what we're going to do now is we're going to start building, okay? So we're going to do a smart recap. We're going to look at 3 questions that we've done in the past, or 3 topics, because we're going to carry them forward today, okay? So the first one is very much about big maths. We've done big maths in the past, but it's going to be used an awful lot today because it tells us the order to do things. The second one is about powers, and you're going to come across powers. Powers relate to numbers, but they also relate to letters, so you need to know what powers mean. And the third question is about negative numbers and or the sign rule. And again, negative numbers or negative signs apply to letters as much as they do with numbers. Let's go through them slow time. So the first one, I said it was about big maths. What am I going to do first with big maths then? Brackets. So I rewrite it. I've got 2 times, do my brackets. 1 plus 3 is 4, divided by 4. And then what do? Left to right, because all I'm left with is multiplying and dividing. 2 times 4 is 8. Divide it by 4, you end up with 2. So hopefully everyone got 2 from big maths. Excellent. The 4 to the power 2, what does that mean in mathematics?
4 times 4.
4 times 4, 4 by itself, which is 16. That applies to letters, or variables as we're going to find out in a minute, as it does to numbers. Minus 4 plus 2.
Minus 2. I've got minus 2.
Got minus 2. How did we get minus 2?
Minus 4 plus...
You start off at minus 4. It tells us to go positive that way. 2 spaces. We end up with minus 2. So the negative numbers applies to negative signs. Yeah? It's all starting to make sense. Yeah? Okay. So algebra. What does algebra mean to you? What is algebra?
Letters and numbers and
Stuff. Letters and numbers is exactly what it is. It's letters when we don't know what the numbers are. Now, last week, previous weeks, I've been putting a question mark down when I said we don't know what something is. All algebra is saying there's a value here, and I'm going to call that value A until I've done the maths to solve this. So in theory, A has a value of 3, because when I actually do the maths, I work out that 3 plus 2 is 5. So algebra is just that. Algebra is the use of letters when we don't know what a value is. And until we're either told what the value is, or we work out what the value is, like we've done here, you can't do anything with it. And so you have to use that letter. You have to manipulate that letter. Okay? So, what we want to do is think of it as maths texting. Because what algebra is, it's kind of a stripped down version of maths, where we don't want multiply and divide signs because they take a lot of writing. And some bright spark said, if we have this text speak in mathematics, if we stick a number and letter together, we can throw away the multiply sign. And that means a 2 and an A next to each other means 2 times A. A B over a 2 means B divided by 2. Okay? So all you're going to see today is how we're going to go from this text speak from shorthand to longhand and longhand to shorthand. Okay? So we start off with this thing called a variable. Anybody know what a variable is? What is a variable in day-to-day life? What is variable other than the weather? Good. Different things, absolutely. So a variable are letters that represent different things. So it's a kind of a buzzword for today, because in the exam the proper word for these letters that we're going to use in algebra is called a variable. So when you start seeing these X's and Y's and A's and B's, in mathematics, our posh word for that is a variable. Okay? So a couple of weeks ago I would have said 1 plus 2 equals, and I would have left it at that. All algebra is saying, I can now say 1 plus 2 equals X. So instead of having a blank at the end of an equal sign, I can assign it to a variable. So when I do the maths, I know that X is equal to 3. Because when I do the maths, it tells me what my variable is worth. Okay? 1 plus something equals 3. Well, we don't use the phrase something in maths. We're a bit posher than that. We have to use a letter. So until we know what the value is, we can say A. 1 plus A equals 3. We do the maths and we say, hey, A can equal 2. Okay? Might not be just 2, but that's hard enough. Okay? So, we've got these things called variables, letters. Okay? And we use it when we don't know something. So, in day-to-day life, can you think of any scenarios where you use algebra? I'm telling you, you probably use algebra 90% of the day without realising it. So what sort of things do you do in the day where algebra might actually be used, but you're not seeing it as algebra? Where you think, oh, sorry? Flipping, chipping. Have you seen my slides? Right. I went for my lunch today, okay? The cost of my lunch is a long sentence, so I'll call it C, is equal to the price of my sandwich, I'll call the sandwich S, and my drink, I'll call that D. So my lunch cost whatever my sandwich was, plus the cost of my drink. Now, before I went to the canteen, I had no idea what any of those were. Okay? They were all variables, they could have been anything. So when I went to the canteen and I bought a sandwich for £2 and a drink for £1, C suddenly became equal to 3. That's all algebra is. You're using algebra every time you go shopping, when you set your alarm in the morning. I've got to be at college for 9, therefore I've got to catch the 8:30 bus, which means I've got to get up, leave the house at 8:15. So you're working backwards to set that alarm. You're using algebra almost all the time to solve things. And that's the prime use of algebra, is solving stuff. Okay? And when you can't solve it straight away because you haven't got all the numbers, you just use letters. Yeah? Okay? So, there's this thing called notation. Okay? So in order to do our texting, we're going to start joining things together. So in words, if I said to you, add 2 to n, how would that look in mathematics if I was writing it as a maths problem?
Is it 2n?
Not 2n. What does that 2n mean? Something specifically different. We'll see in a second. But I want to add 2 to n.
Plus n.
2 plus
yeah.
n. Okay? So in maths, when I'm adding things, you put the addition sign on. Okay? What's the word product mean? Come across it in homework, come across it in the first lesson. Not the sum of, the sum is different. The sum is the result of addition. The product means multiply them. So what I'm saying is multiply n and 3. Does anybody know how you multiply n and 3 in maths?
3.
Sorry?
N cubed 3.
Not n cubed 3?
N times 3.
N times 3, yeah, so it's that, but how do I make that into shorthand in maths?
3n.
Good.
Oh yeah.
Now why have you said 3n and not n3?
Number comes before letter.
Brilliant. Okay, so when we're doing our texting, there's a certain set of rules that we've got to adhere to. The first rule is you get rid of the multiply signs. We don't do multiplies in our text speak. Okay, so we get rid of that. The second rule is you put numbers before letters, so it becomes 3n. And then there's another rule we haven't got on here, but you'll see on the next page, and that is you have to do things alphabetically when you have letters. So if I was multiplying S and R together, our text rule says get rid of the multiply sign, put them together, but you wouldn't say SR, you say R and then S. And RS means R times S. Okay? So we're going from longhand to shorthand. Don't worry about that, we're going to get some practice in a second. Okay? And then Z divided by 4. If we were writing it in maths, it would look like that. But not in algebra. Algebra is text speak. So how would I write that? We've got something.
4 with
The other way around.
Z with the 4.
Z is being divided by 4. So in algebra, whenever you see a division question, it isn't going to have a division symbol, it's going to come across as a fraction, because that's what a fraction is. A fraction is a division's a fraction. Yeah, we spent a whole lesson doing that one. Okay? So there are some certain rules to working with our sort of text speak. Okay? So what we're going to look at now is going to look at our rules, how they apply to addition, multiplication, subtraction and division. So if I say I've got C, I don't care what value is, and I add another C, what have I got?
2 letters.
2 what?
C, 2 C.
2 C's. 2 C. Can everyone see that? Yeah? 2 times C. So if I've got a C and a C, I've got 2 times C. I've got 2 lots of C. I have a C and I take a C away. What am I left with? 0. Yeah? If I've got 10 and I take away 10, I've got 0. I have B and I multiply it by 1. And this is the one that a lot of people get wrong. Okay?
1B.
No, just be itself, isn't it?
Good. It's B itself because
Yeah, that's
one of
what
anything, it's just B. B itself, yeah. Okay, I see what you're saying. Yeah. Okay? And they'll try and trick you. A lot of times in the exam, you'll be left with a variable where there's one of them. And sure at eggs, a lot of people will write 1B. But 1B just means B on its own because it's 1 times B. 2 times Z or Z times 2.
Z, 2. 2Z. 2Z. Yeah.
Numbers first,
Yeah.
then the Z. That's what that means. Z times Z.
Z squared.
Everyone see that? That's what a squared means. So just like a number, just like our 4 squared in our startup questions, a letter can be multiplied by a letter to give you a letter squared, Z squared. Q times P.
Q.
P, Q, because we're getting rid of the multiply sign and then we have to arrange them alphabetically. Our little list of rules over there. A divided by 2. Doesn't look like that.
2 with the
A over 2. We write it in fraction form in our text speak. And then finally A divided by A.
What is it? A over A.
Which is the same as what? What's 10 divided by 10?
0.
1. What's 5 divided by 5? What's A divided by A?
1.
Anything divided by itself is always 1. So here I've actually gone from letters to a number. Because if you divide something by itself, it doesn't matter what that value is, it will be 1. Okay? So these are kind of the rules we use to go from longhand to texting. Okay? But it's quite important to understand how that works, because we're going to go the other way in a minute as well. So, I'd like you to have a go at changing these from longhand into text. Now I've colour-coded it for you. The green are the easy, the orange are the medium, the red are the hard. So, okay, so B times 4 becomes
4B.
over this side. X divided by 3. X over 3. We're sharing the love today. At the back, P times P. It's hip to P squared. A plus A, back lefties. 2A, good. 2 A's. E plus E plus E plus E. Centres.
4E. 4E. Sorry.
It's alright.
Sorry.
It's okay. V divided by B. Go on then, Lisa.
B over
I've just put B over B.
V over B. V is being divided by B.
Ah.
C times C times C times C. Front writers. Okay. 3C. C cubed, yeah. It's C to the power 3. Because C times C would be C squared. If there's 3 of them, C cubed means C times C times C.
Technically B 3C though, isn't it, as well?
Sorry?
Is it not technically B 3C?
No, it'll give you a different answer. If you put a number in, let's put the number 4 in. Okay, 3c would be 3 times 4, which is 12. That is saying 4 times 4 times 4. 4 4s are 16, times 4 is 64. So it's totally different. When you add them together, that's when you can use that 3c. If it's c times c times c, it's powers. Yeah, the numbers gets a lot bigger, a lot quicker. And then the last one, anyone get the last one?
I put 3j over 2.
3j over 2, perfect. Anyone get anything different for that one? Okay, good. Excellent. Now what I want you to do is go the other way. So I've given you the text. I want you to tell me what you would do on a calculator longhand. So what are you going to type into a calculator to do these? So the first one, 3a. How could I put that into a calculator? A plus A plus A is technically right, but then if I said what's 25a, you go A plus A plus A plus A plus A plus A.
Obviously.
So there's a quicker way of doing it.
Yeah.
It means 3 times A. The thing that's missing is a multiply sign. Remember text speed. We're just getting rid of multiplies and divides. That's all we do with text speed. D over 3 means what?
D divided by
Yeah? Everyone happy with that? X squared means what?
x times x.
Notice how I write my x's. So you
what
can
word
spot
is
the
it?
difference between a times and an
I've
x.
just put xxx.
Yeah, you don't get extra
Cool.
marks for blowing kisses to the examiner, trust me. GH means what?
G times h.
Yeah, that's all it means. The only thing that's missing is a times. 2EF.
2 times e times f.
Everyone getting these?
Yeah.
Yeah? Happy with that? So all that's missing when we've got numbers and letters stuck together are the multiply signs or the divide signs when it looks like a fraction. The last one then, m squared.
Times m divided by 4.
There you go. Swing back. But what that allows us to do is not be scared of algebra when we see all these numbers and letters stuck together. Okay? Which brings us on to the next bit. We're going to do the next bit now because it's the next logical step. I've got these numbers and letters and we're sticking them together and we're pulling them apart. Okay? What we have to do now is give these letters a value, and that is called substitution. So we use our variables. If I said to you a plus b equals c, could you solve that? I couldn't, because I wouldn't know where to start. What's the value of a? What's the value of b? What do I start with? So what you need with substitution is somebody to give you some values to plug into here. So you'll get a question along the lines of what is c if a equals 2 and b equals 3? So what I would do is generally write the question out again. 2 plus 3 equals 5, therefore c equals 5. Okay, so all substitution is doing is taking a value for your letter and putting it into whatever it's telling you to do within the equation or the expression. Okay, that's all substitution is, and it's really important because next week that's how we plot graphs. Okay, and we'll come on to that in a minute. So if you end up with something that looks like this, 2a equals b. What does 2a mean in mathematics? That's in shorthand. What does it mean in mathematics? Good. 2 times a is equal to b. So what I'm telling you is a has a value of 3. So you just go back to this and you say 2 times 3, which is 6, therefore b is equal to 6. Yeah? See what we're doing? We're just swapping the letter for a number. But before we did the swap, we made sure that we went from our shorthand to our longhand so that we do the right thing. Okay? This one here, x squared equals y. So what does x squared mean? X times x equals y. So here it's telling me x has a value of 4. So you swap x for the value of 4. 4 times 4 is 16. Therefore the value of y is 16. Can you see how that works? So substitution is literally swapping the letter for the value, the variable, and you're being given the value. Next week we're going to start drawing graphs. And graphs talk about these things called x and y values. Okay? And they've got these letters specifically. Anybody know why we talk about x and y in graphs?
To do with the axis.
Yeah, the axis. There's an x-axis and a y-axis. Which is the x-axis?
The bottom one.
Goes across in my best Adamant impersonation. Okay? So x goes across, y goes up and down. In order to draw a graph next week, you have to substitute values for x into an equation to come up with a value for y. So when you look at this, it looks quite complicated, but what does y equal 3x mean in mathematics? What does 3x mean?
9.
Yeah, 3 times whatever the value of x is. So what you do in graphs next week is you put in a value of 1 to start with. So if x has a value of 1, it becomes 3 times 1. So y has a value of 3. So when x is 1, y is 3. You can see what we've done there. Put in the value of 2. So when x is 2, y has a value of 6. Does that make sense? Not lost anyone. All we're doing is substitution. I'm swapping the value of x for various values I have along here. Okay? I put 3 in. 3x means 3 times 3. So that has 9. And then 12. And then what you do is you go to your graph and you plot 1 on the x-axis, 3 on the y-axis, and so on. You'll get practice next week. But the reason I'm showing you this now is because all that process is substitution. You're given an equation and you just keep putting different values of x in. Let's look at something slightly harder then. Y equals 2x plus 1 is an equation of a straight line. What does 2x plus 1 mean in mathematics?
2 times x plus 1.
Good. So now, when I go to my table to fill my table out, I put the value of 1 in for x. What do I get thrown out at the other side?
2 times 1.
2 times 1 is 2, plus 1
is
3. And why did you do the 2 times 1 first? BIDMAS. So even BIDMAS is kicking in and helping us. It tells you to do the multiply first when you write it out in full. Okay? Let's do the next one. I put a value of 2 in for x. I get 2 times 2, which is 4, plus the 1 is 5. So my 1, when I put 1 in I get 3, 2 in I get 5, 3 in I get 7, and then you go and plot your graph. Okay? So can you see how substitution works? You can put in a value and it throws another value out. Okay? That's all substitution is. This is the hardest substitution they can give you, when you have 2 different values or 3 different values, okay? So I've broken it down for you. P is equal for 4D plus W. Don't worry about what it means, okay? What does it mean in mathematics? It means P equals 4 times whatever D is plus W. When I swap the values for D and W as 10 and 3, it becomes 4 times 10 plus 3. BIDMAS then kicks in and says you do the 4 times 10 first, which is 40, add the 3, you end up with 43. Okay? So this is substituting 2 variables within an equation. No different from one that we did before. Don't worry, you're going to get plenty of practice in a second. Yeah, so can you see how it works? My advice for doing substitution is write out your original equation or formula in full, as in 4D means 4 times D plus whatever, then put the letters for the numbers, or substitute the letters in for the numbers, and then work it all out. Okay? So here's from an exam, Unit 2, given that A is 7, B is 3 and C is 5, work out the value for A plus 2B plus 3C. And then the second part of the question is work out the value of A, B, C. So this is to test, do you understand what the text speak means? So this is in text speak, write it out in full. Once you've written it out in full, then put the numbers in that replace the letters. Put it in longhand for me. Let's go from longhand. Can't do anything with A, but what does 2B mean?
2 times 3.
And then plus, what does 3C mean?
3 times 15.
Yeah. So then the second step is to now put in the values for those letters. So you've gone from shorthand to longhand to make sure you're going to do the right things. Okay, we now put in the values. A is 7 plus 2 lots of 3 plus 3 lots of 5. BidMaths tells us what to do next. I've got 7 and I add 6 and I add 15. When I add them together, 13 plus 15,
28.
everyone get that?
Yeah.
The next one, not a trick question, it's just checking you understand how to go from shorthand to longhand. So ABC means what in mathematics?
A times B times C.
Good. That's what it means. That's why they're stuck together, because there's a missing multiply sign. So we've gone from to longhand. Now we put the values in. 7, 3 times 5. 7 3s are 21 times 5, 105. Everyone get that? You're getting there slowly.
Yes.
Okay. So can you see how it works? If we can go from shorthand to longhand, it means we do all the correct things with our calculator or with mathematics. You put the numbers in for the letters, and then you just do the maths. And BidMaths will keep you right with the maths. I'll give you another one before I give you something really nasty. So this one, November 2010, Unit 2. Okay? Straightforward. It's question 10. It's quite far on in the paper. Work out the value of 2a plus 3b when a is 5 and b is 8. So, let's do this quite quick then. So what does 2a plus 3b mean?
2 times A times 3B.
Good. And then when I stick my numbers in, I end up with...
2 times 10 times 3 times 3.
And then when I do the maths,
10 times 24.
everyone get that?
Yep.
This is a little exercise, and it's called Code Breaker. And I want you to work in teams of 2s or 3s. And what you have to do is you have to do substitution to work out the missing letters. We're going to talk about definitions of these 4 words. Okay? It's going to take 10 minutes. You've just got to put them in your head. We'll go through them again tomorrow just to reinforce it. But you have to know the definition of a term, equation, expression, and a formula. And you have to learn them, because they're going to ask you to circle the expression. Or they might ask you a question and say, write down the formula for this, or the equation for that. And if you put the wrong thing down, you're going to start shedding marks. Okay? So we're going to cover each one of these one at a time, just to show you what they are. And then we'll do a recap. Okay, the first word, term. What is a term?
We still 3A and 4B are terms.
Good. 3A and 4B are terms. So when we start attaching these numbers and letters together, in other words, the shorthand, and getting rid of the multiplies and divides, or just a letter on its own or a number on its own, it's called a term. So, terms are things like 5f, which we now know means 5 times f. 2ab, which we now know means 2 times a times b, is a term. So when we have these things that are really close together and we've removed the multiply or divide signs, in mathematics it's called a term. Okay? Don't forget, a number on its own or a letter on its own is also a term. So the number 5 is what we call a number term. Okay? So in this instance, 3a we know is 3 times a, but that's known as the a term. D divided by 3 is known as the d term. X squared is known as the x squared term. And an x squared is something very different from x on its own, and you'll come to see that tomorrow. Okay? So a term is where we have numbers and or letters stuck together or on their own, and that's it. And the way to spot a term is it won't have any adds or subtracts. Okay? It might have a negative number, but it won't be adding them or subtracting them together. So what do we think an expression is? So we've got our terms. What do you think we're going to do with these terms?
Express them.
We are going to express
Bring
them.
together.
And how do we bring them together?
Add and multiply.
No, not multiply. If they multiply, we get rid of the multiply
Right.
sign. We're
Divide.
not going to simplify. We're going to put them together using add and
Minus.
subtract. Posh word for maths. Okay. So, an expression is where we start joining terms together. And the only way you can start joining terms together is add them and subtract them. So 5f is a term and 2b is a term, But when I start sticking them together, kind of add and subtract are like the glue. Okay? So when you're going to start adding and subtracting terms, it's called an expression. Okay? So 5f minus 2b is an expression. 2ab plus 3 is an expression. Because ab is an ab term, and the number 3 is a number term. Okay? So when you start seeing pluses and minuses with these terms, you know it's an expression. But the biggest single giveaway that something is an expression is there's no equal sign. Okay? So when they ask you to write down an expression in the exam or spot the expression, the really big giveaway is you'll have a term, a plus or a minus, and then another term. Okay? So we know what it means in longhand. We know that 5f means 5 times f minus 2 times b. That's just an aside. What you need to remember is that this is an expression. Okay? There's no equal sign, and I'm joining two terms with a plus or a minus. Okay, brings us on to our next word. An equation. What's an equation?
It's a big sum, a long sum.
Yeah, we used to call it a sum. All we now know sum means adding two numbers, don't we? So, but it's a problem, a maths problem, yeah, that needs solving. So, we'll go along with that. An equation joins terms, but has an equal sign with something on the other side of the equal sign that you can solve. Okay, so 4 plus a equals 6 could be an equation because it's something we can solve, and there's an equal sign, which means it's very different to an expression, and we've got something on the other side of the equal sign. So that becomes an equation. Okay? So an equation is an expression, but it's got an equal sign and something on the other side of the equal sign that generally we can solve. Yeah? We're happy with that. So we've got our term, our little individual numbers and letters scrunched together. We've got expressions which join them with pluses and minuses. We've now said an equation, we've introduced an equal sign and something on the other side of the equal sign. We're now saying there's something called a formula. What do you think a formula is?
Is that simplifying it down like 5 plus?
Oh no, that's tomorrow. We'll do some simplifying tomorrow.
Is it something like you use in science?
Yes. Anybody know any formula? Any famous formula? Oh, yeah, somebody said it. E equals mc squared. So a formula is very much like an equation, but it tends to have two or more variables that you can't even begin to solve until you are given more information. So a formula is something like distance equals speed times time. D equals st. Okay? I can't even begin to tell you how far you're going to travel until you tell me that you're travelling at 10 miles an hour and you do that for 4 hours. So a formula generally has more than one variable that you can't even begin to solve until you're given more information. Okay? So a formula. So here, D equals st, quite literally means D equals s times t, and when I substitute my values in, 10 times 4 equals, I have a distance of 40 miles. Okay? But I couldn't even start this, even though I knew that distance equals speed times time, until I was given more information. So the sequence: a term, an expression, an equation, and a formula. Okay. Which one is a term, an expression, a formula, or an equation? So here are 6 statements. A equals LW, P on its own, 4n plus 2 equals 6. What I want you to do is write down whether you think it's a term, an expression, an equation, or a formula for each of those 6. Write down what each of these is. A equals LW. Formula, okay? Its area equals length times width. That's what it means. But it's a formula. I can't even begin to solve it until you tell me the length and the width of something. P on its own is a term, yeah? 4m plus 2 equals 6. Equation, because it's something I can solve and it's only got the one variable. minus 2r. It's a term. And the trick is, the reason it's a term is it's not just got 2r, it's minus 2r is just a negative number. So it's not got anything here to link to, so it can't be an expression, because expressions join terms. So that's just a negative number, so that's a term. 3t minus 4u, that's our expression. And then finally the number 6 is a term. Brilliant. Brilliant, brilliant. Okay? We've talked about the language of algebra. We know this thing called a variable is a letter, and that it can have one value or that was a right. So the first thing we're going to do then is do something called simplifying like terms. So in maths, if I said to you 2 plus 3 equals what? You tell me it's 5. The reason I can join them is because 2 is what? A number term. And what's 3? A number term. So I can actually join like terms. So the fact this is a number and this is a number means I can join them together. It's no different for letters. Absolutely not at all. Okay? So when I say I've got 2 x's and I add another 3 x's, how many x's do you think I've got?
5 x's.
Ah, you see? Maths. Okay? So in mathematics, we can join things that are the same. But remember, you can't join things that aren't the same. So if I say A and I want to add a 2 to it, can I join those two? No. Good, you don't know what A is, so this is an A term and this is a number term. They're different types of terms. They can't go together. You can't do anything there. I want to add a P to a Q. What have you done when you say PQ? What have you done there? What's missing? So what you've done is you've multiplied them. I'm not saying multiply them, I'm saying add them. Good. So what does this allow us to do? Well, when we get expressions with lots of things like this, and you're looking at this thing now thinking, oh, I'll never see that again. You will, because in Unit 3 they'll give you funny shapes and you've got to add the length of the shapes up, and they might put them in terms of x. So you're going to come across this quite a bit over the next few months. I can do something with this and simplify it. The way to simplify an expression with lots of different terms is to start at the left and pick out all of the terms. So what's the first term that I've got? 2. Can you see any other number terms so that I can join all the numbers together? But is it just 2? The trick to doing this is when you spot the other terms is you've got to include the sign that is in front of them, because that tells you what to do with that first one. So I've got 2, and what else have I got? Plus 2. What's 2 plus 2?
4.
Good. Let's look at another term. What's my other term?
X.
3x.
Not just 3x, I'm at positive 3x. It's a positive 3. Okay? It could be a negative, in which case I'm starting negative on the number line. What else have I got x-wise? Good, I've got plus 5x and a positive 2x. So I've got 3x's plus 5x's, which is 8x's, plus another 2. I've got positive plus 10x. Can you see how that works? Yeah? So all we're doing is systematically we're going along and adding all the terms that actually match. Okay? Remember to include the sign that is in front of the term, because that tells you whether you're adding or subtracting. So on this one, let's have a look at this. What's my first term? It's a y term and it's positive. We like that. What else have I got term-wise?
Minus 2y.
So this is telling me what to do with them. I've got 5. I take away 2, so I end up with 3y's. Good. What have I got left term-wise? I've got 3a's.
Plus minus.
And I take away an a. So yeah, I'm positive 3a, so I've got 3a. And I take away an a, so I'm left with
2a.
a positive 2a. Trust me, there'll be times when that's negative and that you'll take away more than you've got, okay? So can you see how we simplify? Yeah? We spot the terms, we start at the left, spot all the same terms, and then whatever's left, we spot the terms. So, I'll give you a word of warning with the red one at the bottom. X is not the same term as x squared. X squared is classed as a different term. So you've got x's, but you can't add them to x squared. They're totally different things, they don't go. Okay, so be careful of that last one. Let's have a look then. First one. A plus 3a.
4a.
Good. That's kind of straight away, I've got an A, and I can add A's to A's, so 4A. The next one, what's my process? What am I going to look at first?
B
What else have I got?
plus B,
How many B's?
2B,
So I've got a B, and I'm adding 2 more B's.
3B,
I've got 3 B's. And then what's the other variable I've got?
plus 5,
And I got plus 5, I take away 4,
1, plus 1.
not, yeah, positive 1. Did everyone get that one? Good. Talk me through it. Anybody else? Good. X is my term, and then I've got any more. So how many X's have I got? Good. And then my other, got 4 Y's. Take away 2 Y's, leaves me with plus 2 Y's. Perfect. Last one, bit tricky. Anyone brave enough for that one?
Can I do it?
Alex, or let Alex have a go, and then you can correct him if he's wrong. Tell him if he's right. 5x.
Plus x equals 6x.
Good.
5 minus 5 is
5 minus 5 is nothing. So what do you do? Nothing. Brilliant, Brad. Do nothing. They cancel each other out. So things cancel each other out. They're gone. And then finally,
3x times
we've got a minus the 3x squared. Happy with that? And that's as kind of hard as it gets. Okay? So that is what we call simplifying in algebra. Here's one from an exam. Unit 2, March 2011. Okay? Question 10, it's quite far in the exam. The first bit relates to something we did yesterday, so put the correct notation for m times 5, and here's a simplification question. Pretty typical. They're not going to flower algebra up for you in the exam. They're just going to ask you straight out, simplify this. Just like that. So, let's simplify this fully, okay? So, how do I simplify m times 5?
5m,
And what do I get? Good. So the number comes first. So they're checking that you understand the number comes first. If you put m5, you've lost a mark. Quite literally. Okay. Simplify fully. 2a plus 5b plus 3a minus 2b. So what am I going to do first? Look at my a's. Good. So I've got 5a's and then good. So I've got 5b's and I take away 2 of them. Good. Everyone get that? Let's have a look at this one then. Just in the same way that you can simplify things by adding and subtracting them, you can simplify algebra when you get this notation, and it's saying 2x divided by 6. That's what it means in algebra terms. Okay? But you can look at that and you can see something that's very familiar. What does it look like? A fraction. And we can simplify fractions, can't we? What do we do when we simplify a fraction? You halve it. You find something that you can divide the top and the bottom by, okay? So in this instance, what can I divide the top and the bottom by?
2 by 2.
2. So if I divide the top by 2, what do I get?
1x. Just x.
Ah! Spotted it. Okay? 2 divided by 2 is 1, but we don't write 1x. And this is one of the ways they'll catch you in the exam on whether you understand it. Okay? And then 6 divided by 2 is 3. In the same way, they will try and catch you out with something like this. They'll give you this straight out. You'll see an example from an exam in a second, where they'll say 12z over 3. You can simplify it exactly the same way as you simplify a fraction. So let's do that. What's common to the top and the bottom? So what do I end up with then? If I divide the top and the bottom by 3, I end up with 6z. What haven't I done? I haven't written that. Because Bradley knows that anything divided by 1 is just itself. Yeah? 25 divided by 1, 25. A divided by 1 is just A. So when you get these questions, they're trying to trick you into putting over 1 or 1x. Okay? So that's 6z. That's how that simplifies, because both the numerator and the denominator divide by 3. Okay? So, have a go at those two. Tell me what they simplify down to. Okay, everyone had a go at those. So what does 2p over 8 simplify to?
P over 4.
Everyone get that? P over 4. Because 2 goes into the top, but we don't write 1p, we just write p. 8 divided by 2 is 4, so it's p over 4. The second one then is 4 over 1 r. but we've just said anything divided by 1 is just itself. Yeah? 100 divided by 1 is 100. So 4r divided by 1 is just 4r. If you wrote that in the exam, you wouldn't get the mark for it. And you're sitting there thinking, oh, they're not going to test me on that. Here's an example. Simplify that, and then work out the values of that. So there's a question. So what's 3m plus 4m?
7m.
7m. Simplify 12x over 6. What do we get over this side? I'm very quiet over here. I haven't heard a word from you, Robert, Ali.
2x.
Good. Brilliant. Nice one. Dylan, thank you. 2x. Everyone get that? Yeah? And then finally, 2t plus 3u. So 2t means what? 2 times t. What does 3u mean? Good. We swap the letter for the number, so it becomes 2 times 5 plus 3 times 4. Big Maths tells us what to do next. Good. 10 plus 12, and that gives me an answer of... Everyone get that? Good. Let's catch up on some time, okay? Be careful about this thing about powers, okay? About indices. You can add things that have the same index. So the reason I can add 2a to a and get 3a is there's an invisible 1 there. They have a power of 1. Can I add a to a squared? No, they've got different powers. They can test you in the exam, they don't do it every year, to see if you understand that rule. And what they do is they'll give you that to simplify. Okay? So what's my first term? Where are my other a's?
3a.
Plus 3a. So I've got 5a's. Good. Then what have I got to add? I've got a plus a squared, and I add another 2a squared. So how many a squareds do I have in total? So nothing changes. The rule is still the same. You can add like terms, even though the term might be a squared letter, okay, a squared variable. Okay, we've done the first of the 3 things we need to do this afternoon, which is simplifying. The next thing we're going to do is something called multiplying out brackets. Anybody come across this before? A few nods, I would expect you to. Anybody remember how to multiply out brackets? What's the rule for multiplying out brackets? No? Let me jog your memories.
If it's something in the bracket, it's times by the number before the brackets.
Brilliant. Anything inside the brackets, each of the terms inside the brackets, so you've got to split them into terms again, gets multiplied by whatever outside the brackets. So in mathematics, when 2 is next to a bracket, it means 2 times whatever is inside the brackets. So here, it becomes 2 times a, which is 2a, plus 2 times b. The point of that is, I get exactly the same answer whether I do big maths and add these 2 together that I do if I do multiplying out the brackets and use numbers. You will always end up with the same answer, which is why you can do this. Okay? In mathematics, it's called the distributive law. They won't ask you to define the distributive law or use the words, but they'll test you on the distributive law by asking you to expand brackets. Okay? So if we were doing it with numbers and it was big maths, what would I do first here?
Add them together.
And I would get 8. And 2 next to the brackets means 2 times 8, which would get 16. Just to show you this works with numbers, and it works for letters, it's exactly the same as 2 times 3, which is 6, plus 2 times 5, which is 10. So I still get 16. I still get the correct answer. Can you see why we do it? The advantage of this in algebra is, if I don't know what one of these terms are that are inside the brackets, I can multiply them out and go on and do other things with that equation or expression. Okay? So, with letters, when we introduce letters outside the brackets, so instead of having a 2, and we use a variable, you can still do the same thing. So here I've not got a number in sight. They're all variables, A, B and C. So big maths would tell us to add B and C and then multiply it by A. But now we've got a process for expanding the brackets, I can say A times B is AB and A times C is AC. So I've got another way to address things, okay? So here's another example. I've got a variable x outside the brackets and I've got x minus 3 inside the brackets. So the first thing I would do is multiply the first term, x, by this thing that's outside the brackets, x. So I end up with x squared. I then multiply, use my sign, negative, and then I multiply x by 3 and I get 3x. Can you see what I'm doing there to expand brackets? You happy with that? You can do it in one of two ways. You can do it by multiplying whatever's outside the brackets by each of the term insides by using Pete's arrow system. Just show the examiner what you're doing. Or you can do it by the grid method, where you put each of the terms that are inside the brackets into their own boxes. So A is a term, minus 3 is a term. And then the term that's on the outside of the brackets you can stick here and just go A times A is A squared, A times minus 3 is minus 3A. Okay, so have a go at expanding brackets. So I've got 2 brackets x plus 4. What's my starting point?
2 times x.
2 times x gives me,
2x.
good. And then the second thing
2 times
gives me, everyone get that for the first one? Yeah? The second one then, I've got 4 brackets x plus z. Go on then Adam, talk me through it.
4 times x
Is
4x.
good,
And then 4 times z,
yeah?
which is 4z.
And what have I got in between them?
Plus
Good. Next one, b times b is,
2b.
b squared.
No.
b squared.
B squared.
that's what it means, that's why we talk about the shorthand. B times b is b squared, okay? And what's my sign? Good. Thanks, Robert. B squared minus b. I've got x brackets x minus 2y. What's the first thing I'm going to do?
X squared.
X times x is good. My sign is minus. And then what's the next thing I'm going to do?
2.
yx.
yx.
2yx.
2yx, 2xy. I like that better because x comes before y. So it's 2xy. Brilliant. Anybody try the red one?
Yeah.
And then try again.
Go on and try again.
Minus a plus a is going to be
Not plus a, times a.
times a is going to be a squared.
No.
No, isn't
What's
it?
a negative times a positive? Minus a squared. Good, Ayaz. So that's the first bit.
And then is
And then a minus a times minus 2. So a minus times a minus is a
plus.
plus. And a times 2. Good man. Yeah? Did you get that?
No.
Oh. You nearly made my day. Right. Everyone happy with expanding brackets? Just to show you, this is how it appears in an exam. What's the first thing I'm going to do?
W times w.
W times W gives me what?
W squared
And then what am I going to do?
plus 6w
The plus sign, and then W times 6. The right way round, numbers first, 6W. Everyone get that? Yeah? Good stuff. What's factorising? What's it all about?
Factors.
Factors, good. What's a factor? Not just a number.
When you make it smaller.
You make it smaller. Yeah, you can make it smaller. But it's about numbers or letters that go into
What is
other numbers or letters, not just one in itself.
So what
It's-
times
It's like times tables, right? But with letters. And what it is in algebra is putting things into brackets by looking at something that's common to this, like your times tables. Okay? So, might sound funny, I've got 2 terms. I've got an x term and I've got a number term. But there's something common in both of them. What is common to 6x and to 8?
Oh, right, when you move the 6 over to the. Oh, no, there's no equal, never mind.
There's number terms in both.
Yeah, there's number terms in both. So what number is common to both? 2. 2 goes into 6. 2 also goes into 8. So I can actually Do the opposite of what I was doing, which was expanding brackets. Factorising in algebra is putting things into brackets. The way to do that is to find something that is common to each of your terms. So in this case, the number 2 is common to 6x and it's common to 8. Then what you've got to ask yourself is, what do I multiply by 2 to get 6x?
3x.
Can everyone see that? Because 2 times 3 is 6, and I need an x in there as well. Put in your plus sign, and then ask yourself, well, what do I multiply by 2 to get 8? Not hard, is it? Eh? Somebody earlier on said they struggled with factorising? Can't see why. Let's try another one then, okay? I've got 3a plus 3. Let's look at the process for dealing with this, okay? What's common to both of those?
3.
The number 3. So 3 goes outside your brackets. You then have to ask yourself, what do I multiply by 3 to get 3a's?
A plus
A. Okay? So you end up with 3a. You then have to ask yourself, to get my second term of 3, what do I multiply 3 by to get 3?
1.
Good, 1. So you end up with 3 outside the brackets and a plus 1 inside the bracket. Okay? Just another example and then we'll do a few. I've got 3a plus a squared as my 2 terms. Okay, it's my expression. What's common to both? A. So you take a and you stick a outside the brackets. You ask yourself, what do I multiply by a to get 3a's? 3. So 3 is your first term inside the bracket. You then ask yourself, what do I multiply by a to get a squared? A. So your second term is a. So outside the brackets you've got a, and inside the brackets you've got 3 plus a. Can you see how it works? Let's do 4 together and then I'll give you some to do on your own. Okay? The reason I'm doing some more examples is factorising is the one thing almost everyone gets wrong when we start our practice papers in November. So remember, it's putting things into brackets by finding something that's common. So what's common to 5p minus 25? 5. Ask yourself, what do I multiply by 5 to get 5p? P. Because 5 times p gives me my 5p. Put in your minus sign. What do I multiply by 5 to get 25? 5. Good. It's actually easier with letters. I've got mn plus mt. What's common to both? What do I multiply by m to get mn? What do I multiply by m to get mt? See how it's easier with letters for some reason. I've got a squared plus ab. What's common? A. What do I multiply by a to get a squared? What do I multiply by a to get ab? Who said maths was hard? I've got 9xy minus 3y. This is the red question. What's common to both of those?
3.
The number and the y.
Ah, brilliant. So 3 and y.
3.
So both of those two are common. What do I have to do to get from 3 to 9? 3. What do I get from y to xy? X. Good. Minus sign. I've got 3y. I want 3y. What do I multiply it by?
Y.
Just 1. 3y times 1 is 3y. Okay? Have a go at those 4. We're nearly done. Don't worry. This question. There's a couple of examples and we're done. First one then. Mo, talk to me. What's common?
6.
What goes inside the brackets? Don't tell him. Let him do it on his own. He's doing fine. Put in the plus sign. And then... Good. Yeah? Everybody get that? When you're factorising, you're looking for the biggest number that goes into both. So if you've used 2 or 3 outside the brackets, in theory it's correct, but it doesn't get you the marks because it's got to be the highest factor that goes into those two. Next one. What's common to these? So I've got A as the thing that's common. What do I multiply by A to get C? What do I multiply by A to get AB? Good. Next one. Guys at the back, you've gone quiet on me. Talk to me again. Good, W's common. W times W gives me like W squared plus. Good. 3z. Fantastic. Final one. Who's brave enough for the red question, other than Carol? Anyone want to try the brave? Go on, NS.
4v would be common.
4v. Good. So 4v is common. Excellent. So that's the thing that's outside the brackets. Times it by t gives me my 4vt. Plus is our sign. 2 to get from 4 to 8. And then I've got a v and I need an r. See how that works? Yeah? Excellent. Just to show you how they ask you in an exam. So question 9 in an exam says factorise fully 4t minus 20. Not going to insult you. Let's do it together. What's common to both? 4. The number 4. Okay, what do I multiply by 4 to get 4t? What do I multiply by 4 to get 20? 2 mark or 1 mark in a bag. Took about 30 seconds. Yeah? Good. Where would I start? Good. 2x. Is good.
And then obviously 4 times.
Yep. Good. Perfect. That is the perfect first step. Step number 1, expand the brackets. Step number 2, simplify. No, Matt's on a roll. Go on then, carry on. You're doing brill. Absolutely brill. What's next?
6x.
We've got 2 x's, so we're just simplifying. Just simplifying. 2x plus 4x. And then I've got plus 32 minus 20 plus 12. Step 3 is factorising it. What's common to both? 6. What do I multiply by 6 to get 6x? Good. What do I multiply by 6 to get 12? So looking at the format of that, what is A? And what is B? So that was the 3 basic processes we learned today. Expanding brackets, simplifying, and then factorising. Okay? As far as the lesson content is concerned, that's it.